All right, so I wanted to take a minute to revise our work energy principle. So up until now, we have been writing the work energy principle like this, right? The net work on an object has to be equal to the change in kinetic energy of that object. However, this was only when we were defining our system as a single object. And a single object on its own can only have kinetic energy. But now we are revising that, and we're going to start looking at systems that consist of multiple objects, which we did during conservation of energy, but now we're actually looking at those as open systems, and we're considering whether energy can flow in or out of those objects. So we are going to revise our work energy principle, and now it's going to look more like this, right? The total work done on a system, total work done on a system has to be equal to the change in the total energy of that system. Right? And what this means is that, right, when an external force, right, only external forces can do work on a system. They can change the energy of that system, and they can change it in multiple ways. Right? So for example, if we have a mass and we lift it up off the surface of the Earth to here with some external force, right? So there would be an external force pushing up on the object to do that. Well, the work done by that external force, right, the work done by the external force could contribute to a change in the energy of that system, because, right, that the mass Earth system together, it actually has more potential energy than it had before, even if this box starts and ends at rest. Right, so even though the box didn't gain any kinetic energy, this external force did work on the mass Earth system and gave that system potential energy. Right, so this is just a kind of a quick example of that. And I think LOL diagrams will make this, or should make this really, really clear. So go ahead and check out my first example video, and then there are some questions I want you to try out.